Okay, this is the fifth and final video about quadratic functions. In this video, we will learn about solving and graphing quadratic inequalities. There'll be some shading going on and such. Now look, don't get this process confused with problems like this. Sometimes we'll have problems that look almost the same, like x squared minus 4x minus 12. But instead of having a y, it'll be like less than 0. Only x's. When there are only x's, we sort of solve it like normal, but we'll make a number line graph. So it'd be like -3 and 4 or whatever. And maybe it'll be like this, or that type of thing. Now, that's what we do when there's no y, when it's just x. Now, when you have a function and it's like y is less than, that's when you have to draw the parabola and there's going to be shading involved to determine, to reflect where the solutions are. So basically, we need to draw this parabola. Okay, the really easy way to do that is just to go straight to the table function of your calculator. Okay, so it's x squared minus 4x minus 12. Okay, just hit enter until you get it going on. Now, I usually just scroll up. I'm looking for whatever values will fit. I know my graph only goes up to 10. So here I have -3, 9. That's as far as it'll go. So I'm going to just graph that right off the calculator. Okay, so I've got -3, 9. And then -2, 0. And then -1, -7. And 0, -12. This is a very large parabola. 0. Alright, this is way off the graph. Interesting. Alright, I'm just going to keep graphing. It's bothering me that this is going off the graph, but let's just deal with it as best we can. Okay, let's use our imagination. Alright, I cheated and extended my graph digitally. But you just go ahead and graph your points below as best you can. Just estimate and we'll just deal with it. Okay, so where was I? Okay, I was figuring out what in the world was going wrong, but let's go back to 0. So at 0 we had -12. Okay, so this is -12 would be right here. And then at 1 we're at -15. Alright, so that's -12, 13, 14, 15. Okay, and then at 2 we're at -16. Alright, and then after that it starts to come back up. So at 3 we're at -15 again, and then we can start following the pattern. So the next one is going to be here because of that. The next one's going to be here because of that. The next one's going to be here because of that. And the next one is going to be here because of that. Okay, so I'm going to have to zoom out because this is so big. Alright, so go ahead and graph the parabola. Be careful about one thing though. For this type of problem, sometimes it will be a solid curve and sometimes it will be dotted. Do you know which it will be in this case based on this symbol? It's going to be a dotted line. Alright, just like we have open circles when it's just less than or just greater than, and we have a closed circle when it's like greater than or equal to. Well, a dotted line is like an open circle. Okay, it shows that the border line is not to be included in the solution. So make sure you draw it as a dotted line is my point. Alright, so your parabola should be looking like this. Now, the shading. We need to shade this either in here or outside here to show where the solutions are. And there's two ways to think about knowing where to shade it. One way is the above or below method. So when I look at this, I see that it's saying, hold on, y is less than the function. Okay, so because it says less than, I know that I want to be below the function, below. So for example, start at the vertex. If I go right on the vertex, I'd be right here. If I go below the vertex, then I'm like right here. So that I know that this is below the function. Now, see how it's also sort of outside the function? So everything that's below the function then is going to be out here. Alright, all of this is going to be considered below the function. All of this, alright, it's going to be like the outside part, which I'm going to shade in better in a minute. Okay, so that's one way to know by just thinking above or below. If this had been greater than, I would have gone above the vertex, and that would have put me in here, and I would have shaded in here. Alright, so when you're all done, this is what your graph should look like. And of course, the shaded zone represents where your solutions are. Now, there's another method other than the above-below method for deciding where you should shade. So I'm just going to mention that. And that's the test point method. You pick a test point. I usually use 0, 0 as my test value. Okay? You pick a test point and plug it in to the equation. It will either make a true statement or a false statement. If it makes a true statement, then it's a solution. And everything else where it is will be a solution. So if 0, 0 made a true statement, that would mean 0, 0 is a solution, which would mean everything in here would be a solution, and I would shade it in. If 0, 0 makes a false statement, that means this is not a solution, which means that none of these things are solutions, which means that the solutions must be outside. So in other words, 0, 0 is what I'm looking at. That's x and y. So if I plug that in, this would become 0 is less than 0 squared minus 4 times 0 minus 12. Alright, so this would boil down to 0 is less than 0 squared is just 0, so that's out. Negative 4 times 0 is just 0, so that's out. So it's just negative 12. 0 is less than negative 12. Is that true or false? That is false. That's like no, incorrect. So that meant that 0, 0 is not a solution to this inequality. So that meant none of the stuff in here would be a solution, which means that the solutions must be the things that are outside the parabola. Alright, so it makes sense with what we put. So now you know two ways to do it. Alright, last problem, number 27. Again, we need to plot some points. Let's put this in the calculator. Okay, so I have x squared plus 4x plus 3. Okay, let me go back to the beginning. Okay, the first point that fits is -5, 8. Okay, so I will go to -5, 8. And then I've got -4, 3. And -3, 0. And -2, -1. And then it starts to repeat. -1 is back to 0, which means the next one will be at 3 and the next one will be at 8. Okay? So let's graph the parabola. Will this be solid or dotted? Solid, because of the or equal to part. So there's your parabola. All we need to do is shade. So using the above below method, is this going to be, will the solutions be above or below the function? Well, this says greater than or equal to, so that implies the solutions will be above the function. Now again, I like to look at the vertex. It's very clear. Alright, if you're on the vertex, you're on the function. If you want to go above the function, you need to go up from the vertex, which clearly puts me in this part of the graph. Okay, so at that point, that means that all the solutions will be in here. So you should go ahead and shade that in. So that's it. Also, we could have used the test value method. Using the test value method, and again, I like to use 0, 0. Alright, which is of course outside the function this time. If I put in 0, 0, I would have 0 is greater than or equal to 0 squared plus 4 times 0 plus 3. Okay, this part, because of the 0, that's gone. 4 times 0 is 0, that's gone. So all I really have is 0 is greater than or equal to 3. Again, that's a false statement. So that means this 0, 0 is not a solution, which means that none of these points outside the parabola are solutions, which means the solutions must be inside the function. So that's another way we would have known to shade that in. Okay guys, that is it for this lesson. This was the last video. I hope it was helpful, and I will see you on the next video.